At the top, some trigonometric identities are shown. They may be able to help us solve these trig integrals. And we'll also want to use the technique of u substitution for many of these. So when we're doing u substitution, we want to make the right choice for u. We're looking for part of the integrand whose derivative is also in the integrand. Now we could make u into sine x, or we could let cosine x be u. I'm going to choose u equals sine x. Because I know that cosine x is the derivative of sine x. Now I can replace this with u cosine x dx, and I'll plug in the du for cos x dx. This will give us u squared over 2 plus c. And by plugging the sine x back in, we get 1/2 sine squared x plus c. Down here, secant squared of x is the derivative of tan x. So it would be good to let u equal tan x. Du would then be found to be secant squared x dx. We can replace tan x with a u, and we'll also replace the secant squared x dx with du. Getting that. Once again, our antiderivative is u squared over 2 plus c. And our antiderivative of the whole thing then is tan squared x over 2 plus c. Next one's a little tougher. We don't really see a function and its derivative exactly in the problem. So now it may be helpful to use some identities, such as the ones above here, to rewrite the integrand. Well, secant of x could be rewritten as 1 over cosine of x. And tan of x is also known as sine x over cos x. Now this seems like a tough one here, but if we make the right choice, we may be able to integrate it. I'm going to want u to be cosine x this time. I know that the derivative of cos x is negative sine x. And sine x is in the problem. Even though it's not negative, we can still fix that by moving the negative to the other side. Now we can put in 1 over u, and we'll put a u down below for that cosine x, there's 2 of them. And now for sine x dx, put in a negative du. Alright, that's going to have an antiderivative of 1 over u plus c. And so we will have 1 over cosine x plus c, or secant x plus c. Try the last one. Decide whether you want to let u be cosine x or sine x, or perhaps something different. Because we have several cosine x's here, I'm going to let u be cosine x, because it would be really nice to just get rid of them and make a u to the third. And the derivative of cosine x is sort of in the problem. As long as we do a little algebraic manipulation, we can make it work out well. Du is negative sine x dx. Negative du is sine x dx. And we have sine x dx in the problem. This will give us negative u to the third du. Alright, so we'll have negative u to the fourth over 4 as our antiderivative plus c. Negative cosine to the fourth x over 4 plus c. That's our final answer.